Let us solve exercise 2 of the physics exam for first session 2022. Exercise 2. Energy consumed by an electric component. Consider the circuit of document 1 that consists of the following components: a DC generator G of adjustable voltage, an electric component D, an ammeter A voltmeter V, connecting wires, and a switch K. Part 1. We varied the voltage delivered by the generator G from 0 to 10 volts. We record the values of U and I displayed respectively by V and A, the result as shown in the table below. Number 1.1. Draw the characteristic current voltage curve of D. Take the scale on the horizontal axis 1 cm for 10 milliamp. On the vertical axis 1 cm for 2 volts. We'll use the graph paper to draw the graph. First, we will draw the horizontal axis and the vertical axis that represent the current and the voltage. Second, we will choose the scale. So as I mentioned in the given, the scale on the horizontal axis is 1 cm for 10 milliampere. So here, each box is 1 centimeter. So I will take that each box is 10 milliampere. Then we can write the scale on the x-axis: 10, 20, 30, 40, 50, etc. On the vertical axis, each 1 centimeter represents 2 volts. So also we can write them on the vertical axis, which is 2, 4, 6, 8, and 10. Now we are able to start plugging the values of the table to the graph. First one, 0, 0. So here we can plug the first point on the 0, 0. Second one is 2 volt, 10 mil. We can indicate the second point. 4, 20, this is the third point. 630, this is the fourth point, and 1050, this is the last point. Now we are able to join these points and we will get the graph. This is the straight line passing through the origin. Number 1.2, D is a resistor. Justify. So we drew the VI characteristic of D, which we get it's a straight line that passing to the origin. So now we can say that D is a resistor since the UI characteristic is a straight line passing to the origin. Number 1.3, deduce its resistance R. So we know that the resistance R equal to the slope, and the slope is U2 minus U1 over I2 minus I1. And from the table we can take any two values of the voltage and the current. So 10 volt minus 0 over 50 milliamps minus 0. But take care, milliamps we should divide by 1000, so times 10 to the power minus 3 ampere. And the answer will be 200 ohms. You can solve it in another way and directly use Ohm's law, since we know that it is a resistor. So Ohm's law, U equal I times R. And I want to calculate the resistance, so R equal U over I, and you can choose any two values from the table. So we know from the table that 2 volt correspond to 10 milliamps. So 2 volt over 10 times 10 to the power minus 3 ampere equal 200 ohms. And this is the resistance. Part 2. For a voltage across D, U equal 8 volt. Part 2.1. Give graphically the corresponding value of I. So from graph, we can draw a horizontal line from 8 volts till you reach the graph. Then from the graph, we go vertically downward till we reach the x-axis for the current axis. And we can see that it's 40 milliampere. So for U equal 8 volt, graphically the corresponding value of the current I is 40 milliampere. Number 2.2. Show that the electric power consumed by D is 0.32 watts. So we all know that the power equal U times I, the voltage times the current. The voltage here is 8 volt times the current. We already proved that it's 40 milliampere. So 40 times 10 to the power minus 3 ampere, and the result will be 0.32 watt 2. Number 2.3. Calculate in joule the electric energy E consumed by D during 10 minutes of functioning. First, we know that the energy equal power times time. The power, we already calculated it in 2.2. So it's 0.32 watt times, time is 10 minutes, but we should convert it into seconds. So times 60 seconds. And the answer will be 192 joules.